Assalamu alaikum. All right. My name is Wickliffe I'm a medical physicist by profession and a young computational neuroscientist. I wish to take this opportunity to welcome you all to a newly formed channel called Physics of Life Studio. And in the Physics of Life Studio, we're gonna explore how laws of physics are used to govern the living systems, from the cell to the full-blown human body. We shall discuss physical laws to the important matters of applications in healthcare. And this channel is designed for students, for radiography, physics students, biology students, medicine students, medical laboratory students. Now that we are going to do some bit of neurocircuitry, then we have anybody who has inspiration to understand how physics laws can be used to govern the normal operations of the human body. Now, we are going to divide this course into sections. And the first section, which is our basic level, we are going to discuss fundamentally, we are going to dwell more on radiology physics, where in radiology physics we start from atomic structure up to when now we use the atomic applications in the production of images, and we'll discuss about the CT, we'll talk about the ultrasound, the X-rays, we'll talk about the MRI. Then we will endeavor to move to the applications. That is at basic level. We are going to do applications of physics in real life. And under that section, we are going to look at how we sense, how we see, how do the images form in our retina, how do we smell, how do we hear, now that the ear that we have just acts like a mechanical device, just like a microphone. We'll try to explore the ohmic law in response to the blood flow, understand how blood flows, what makes the blood flow. We'll understand what makes the blood flow. Then we'll discuss something of obvious importance, and that is action potential, because action potential is a fundamental key, particularly when it comes to the neuro activities, transmission of signals. We'll see how signal is being transmitted at basic level, so that when we move at the advanced level where we'll be discussing the computational neuroscience, then at least we have a clue of what we are discussing. Now at advanced level, we're going to take a voyage in the understanding of nuclear medicine, because it forms part and parcel of radiology. Then we'll not stop at that point. We will look at mechanics. We'll try to explore mechanics to understand the modern physics. Then we will not stop at that point again. We will try to look at the computational neuroscience. Now that I've said that I'm a young computational neuroscientist, there's an area of interest where we can check, and under computational neuroscience, we will check how we can use the brain signals really to see if we can come up with circuitries that can act as a second reader to the invasive kind of diagnosis. We'll see how we can model the perception, how we think, and maybe from there we'll be able to have a clear picture how we can use the physical or physics principles to the understanding of human life. Now, if you allow me to move to the first lecture. And the first lecture, I've said my name is Wickliffe. The first lecture is going to be on atomic structure. Now, As we know that atoms are made up of three subparticles, and these three subparticles are protons, neutrons, and electrons. The protons are positively charged and they reside within the nucleus. The neutrons are chargeless. They also reside within the nucleus. Then we have the electrons. Electrons are negatively charged and they orbit around the nucleus. Now, this is our nucleus that composed of protons and neutrons, and then electrons hovers around, as we'll be able to see as we move down. Now, if we look at the configuration, as much as the planets orbit around the sun, the same happens with the electrons. Electrons now here are the planets that are orbiting around the nucleus, with our nucleus as the sun. So the basic atomic structure presents atom in this manner, such that electrons orbits around the nucleus, with the nucleus held together here by a strong force, which we will discuss as we move. Now, this kind of model is attributed to the discovery of Bohr and his fellow Rutherford, because Bohr discovered that electrons orbit around the nucleus in some specific quantum, some paths called energy level, whereas Rutherford invented the existence of the nucleus, which caused some repulsions. Now, in the sense of understanding, we really need to know that the number of protons in the nucleus is what determines the atomic number of the element, while the electron number determines the chemical property, because with the electron aspect, we are able to understand whether an element is a metal or a non-metal, or it is a gas. But now the proton number here helps us to determine the atomic number, and is also fundamental when it comes to situating elements in the periodic table. Now we really need to appreciate the fact that an atom consists of three particles, with electrons orbiting around the nucleus in a path called energy levels. And the energy levels have specific amount of quanta that is influenced by the electromagnetic force. The energy within these quantas, these principal quantums, are influenced by the electromagnetic force. And the electromagnetic force is the force as a result of the negative and positive charge attraction, the force of attraction, that as much also respect the Coulomb's law. Now, normally we have several other nuclides in the universe. These nuclides are normally being presented in certain set of scientific standard. Now, normally this is the set of scientific standard that is used to present or to note a nuclide, where this X gives us the symbol of an element, and then we have the subscript down here gives us the atomic number, and then we have the superscript giving us the mass number. Now the mass number, the superscript mass number, is obtained by the adding of the proton and the neutron of an element. Then the atomic number is informed by the proton number. Now maybe we can take an example of carbon. Now an element carbon has a symbol of C. It has a mass number of 12 and has atomic number of 6. Now the mass number here has been influenced by the fact that carbon is atomic number 6 with proton number of 6 and neutron number of 6. So when you add the proton number 6 and neutron number 6 gives you the mass number 12. So that the mass number, the ingredient here is that the mass number is obtained by addition of the proton number and the neutron number. That only gives us the mass number. And if you see this now, it is clearly an evidence that element carbon is atomic number 6. And that is how it exists in the periodic table, because remember, this atomic number, which is informed by the proton number, is what aid us in writing these elements in the periodic table. Now, we also need to appreciate the fact that we have several other nuclides. As I've said, there are more than 3,000 nuclides. And these nuclides, they are classified into 4 classes. And our first class is an isotope. An isotope is an element with the same proton number, but different in mass number. As you can see, we have carbon 12 and carbon 13. Carbon 12 is having atomic number or a proton number of 6, and carbon 13 also is having a proton number of 6. As you can see, they differ in mass number. Difference in mass number is a result of difference in the proton number, meaning that this carbon 12 is having 6 protons and 6 neutrons, whereas carbon 13 is having 6 neutrons and 7 protons. That one makes it an isotope. So an isotope is an element with the same proton number but different in mass number. That one gives an isotope. Now we go to isobars. Isobars is an element with the same mass number but different atomic number. As you can see, we have this one is having molybdenum is having 99 as the mass number. Then they have titanium also having 99 as the mass number. But when you check at their atomic number, they are quite different. This is 42 and this is 43. As much as they border each other, but they are different elements. They are not the same element. They are different, extremely different. So this one clearly shows that this element here is having a less number of protons, and thus we'll be able, neutrons, to be able to appreciate as we move. Now we have isotons. Isotons are elements. They are elements with the same neutron number and different proton numbers. Even if you leave this iodine and the counterpart, we can talk about the carbon 13 and nitrogen 14. Carbon 13 is having a proton number of 7, and nitrogen 14 is also having a nitrogen proton number of 7. So they are 2 different elements, but they have the same proton number. But the difference in what makes them become different is the fact that they are having different they have different atomic number, because carbon 13 is having proton number of 6, while nitrogen is having proton number of 7. That makes them a different element. Once there's difference in atomic number, then makes it a very different element. Now we have looked at about the atomic structure, subatomic particles. We have talked of how elements are. We have talked of how electrons orbit around the nucleus, as informed by the Bohr and Rutherford models, and we have talked of the classification and how the nucleus are being presented. Now, in our next lecture, we are going to discuss about the electron orbitals and principal quantum. Welcome you all to the next lecture, and let's meet in the next lecture. Thank you very much for listening.